Today's topic are looking at different properties of functions, odd and even functions, which we talked a little bit about when we did the trig piece, and also piecewise functions, okay? First of all, you need to know what even functions are, and if you remember from trig, even functions are were cosine and were secant, and if you remember, even functions mean that you get the same answer whether you plug in a negative value or a positive value. If you plug in the opposite number, you're going to get the same answer. That's what even functions means. It also means they're symmetric to the x-axis, which means, of course, that you can fold it over the x-axis like this. So if I fold this picture along this line right here, both halves of it would match up. So notice when you plug in positive 3, you get the same answer as when you plug in negative 3. And that's what an even function means. Okay? This is an example of an even function. You'll learn later that it is an absolute value function. But if I plug in 2, notice I have the same answer as if I plug in negative 2. Okay? Same thing. All right, so we want to first of all discover if this is an even function or not. X squared plus 1. So when you plug that in, what you want to check for is if you plug in numbers that are the opposites of each other, do you get the same answer? That's what you want to find out. You can pick any number you want. I'm going to plug in 2. Okay, when I plug in 2, I have 2 squared plus 1, which of course is 5. When I plug in negative 2, I have negative 2 squared plus 1. And remember that you need to square negative 2, not write it like this. This is something different. If you want to actually square negative 2, that needs to be in parentheses. But when I square negative 2, I get 4 plus 1, which of course means I get 5. So in this case, when I put in opposite numbers, I got the same answer. So yes, it is even. And on a quiz or a test, I will expect more than just yes. I will expect you to prove it to me by doing something like I just did right there. Okay? This is the graph, just so you know, of that previous function, x squared plus 1, and you can see that it does fold over the x-axis. It is symmetric over the, not over the x-axis, sorry, over the y-axis. And so it is an even function. Okay, here's another function, x cubed minus 1. Again, I'm going to pick any number I want for x, plug in its opposite, and see if I get the right answer, or the same answer. I am going to plug in 3 in this case, just because I want to. So when I plug 3 in, I'll get 3 cubed minus 1, which of course is 27 minus 1, which is 26. When I plug in negative 3, I will have negative 3 cubed, which remember is negative 3 times negative 3 times negative 3, which of course is negative 27. So negative 27 minus 1 is negative 28. And you can see that I do not get the same answer. And so no, this one is not even. And again, I will expect some sort of proof on a quiz or a test other than just a yes or a no that it's even or not even. Okay? And by the way, here is the graph for x cubed plus 1, and you can see that it does not fold symmetrically over the y-axis, and so it is not an even function. Okay? Oftentimes the powers will give you a hint. It doesn't always work, so be really careful about that, but it can give you a hint. Oftentimes when you have a power in there that is an even exponent, it will be an even function, and if it's an odd exponent, it will often be an odd function. Doesn't work always though, so be careful. Okay? Then there are odd functions. Odd functions are where when you plug in the opposite number, you get the opposite answer. So if you plug in 3 and you get 9, you need to plug in negative 3 and get negative 9 in order for it to be an odd function. So odds are opposites. They are also symmetric about the origin, which means you need to be able to fold like kitty corner. You need to fold quadrant 1, this quadrant on here, over the origin. So you're going to fold it diagonally onto quadrant 2, and it has to match up. So this blue line, if you fold, so you're basically folding it over this line right here, or you could fold it over the other way too. So you could fold either quadrant 1 onto quadrant 3 or quadrant 2 onto quadrant 4, but you're folding it diagonally basically. So if you fold it kitty corner diagonally, you can see that that blue line would match up, but the red line, if you fold it diagonally, would not match up. Even if you fold it the other way and get quadrant 2 onto quadrant 4, it is not symmetric about the origin. So That should give you a hint. Okay. All right, so here's another one, and I am going to try plugging some numbers in. Okay. Here's my function. I'm going to plug in, I don't know, let's plug in 2 this time. Okay. F of 2 would be 2 squared. Whoops, I forgot to write my 2. 2, not 2 squared, 2 cubed, sorry. Let's just start over. And 2 cubed, of course, is not 2 times 2, but it's 2 times 2 times 2. Or 2 times 3 is, yeah. It's not 2 times 3, which is 6. It's 2 times 2 times 2, which we know is 8. Okay? Then I'm going to plug in the opposite, which is negative 2. And if I plug in negative 2, I have negative 2 cubed. So negative 2 times negative 2 times negative 2 is negative 8. And when I plugged in the opposite number, 2 and negative 2, I got the opposite answer, 8 and negative 8. So yes, this is odd. Okay? An odd function. So that's that. And again, often if you have odd exponents, you'll have odd functions. Not always, though, so be really, really careful about that. Okay? The next question is this one odd or even? So again, you're going to plug in different numbers. Let's plug in 2 this time again. When I plug in 2, I have 2 to the 8th power, which I don't know what that is. But when I plug in negative 2, I have negative 2 to the 8th power. So you better put those into your calculator and figure out what they are. 2 to the 8th power, I suppose I could do that in my head, but I'm not going to. So 2 to the 8th power is 256. And when I do negative 2 to the 8th power, I also get 256. So these are the same answer. When I plugged in opposite numbers, I got the same answer, which means that this is even. Okay? And there's the graph of that, so you can check that it is symmetric to the y-axis. Here's another one. Again, I am going to plug in a number. I am going to plug in 3 this time. So 3 squared plus 1. 3 squared is 9, plus 1 is 10. When I plug in negative 3, I get negative 3 squared, which is 9, plus 1, which is 10. Okay? Again, plugging in the opposite numbers gave me the same answer, so it is even. Okay? There's my equation, just so if you want to see it. When you plug in x. So here, if I plug in, let's say, 4, I get 4. When I plug in negative 4, I get negative 4. Plugging in the opposite number gives you the opposite answer. It is odd. Notice it does have an odd exponent on it as well. And there's that. Okay. Here's another one. When I plug in 5, let's say, f of 5 is 5 plus 1, which is 6. F of negative 5 is negative 5 plus 1, which is negative 4. Okay, so here, when I plugged this in, I did not get the same answer, nor did I get opposite answers. And when that happens, then it is neither even or odd. Okay, and there's my graph. All right, just a quick little reminder that you need to be able to find the equations of some lines because we are going to be working on some piecewise functions here. Remember, in order to find an equation of a line, you need to know the slope and you need to know the y-intercept, or you can plug things into y minus y1 equals m times x minus x1. We'll kind of figure that out. But this one is really easy to do by the slope and the y-intercept. So it crosses the y-axis at 1. It has a rise over a run of 1 down and 1, 2 to the right. So on this equation, my slope would be negative 1/2 because I moved 1 down and 2 to the right, x, and then my y-intercept, it crossed the y-axis at 1. So that's what that would look like. Okay, just a quick reminder. All right, here's an example of a piecewise function, which has some different parts to it, and your job is to be able to figure out the equation of the line at all the spots, and then put some stipulations in them about what the domain and range are. Okay? So for this spot right here, we're going to call this little part of it A. Notice this has the coordinate negative 3, 0, and this has the coordinate negative 2, 2. Okay? So for part A, right here, I am going to follow this equation, and I'm going to sort of figure this out. So my rise over my run here, my rise would mean to get from here to here, I go up 2 and I go right 1. So up 2 and right 1 gives me a slope of 2. Okay, so I have y minus, I'm going to use this coordinate, it doesn't matter which one you use, but y minus 0 equals 2 times x minus my x coordinate, which is negative 3. Of course, boom, boom, and that becomes positive. And then I will get y equals 2x plus 6. Okay, now, that's that piece, but that's not the whole entire graph. So you need to stipulate where that graph is for. What x values is that graph for? Okay, and that graph is only good when x is between negative 3 and negative 2. So you need to figure that out. So I'm going to write this for. So this is my equation for that piece of it. Okay. Then part B, of course, is a horizontal line. Notice that has an x value that goes from negative 2 up to, I am going to assume that this is 1/2. I'm kind of assuming, but we're going rough here, okay? So obviously that's a horizontal line, and that horizontal line always has an equation of y equals, and in this case your y value up there is 2 in this region right here. Your y value is 2, but again you need to stipulate for which x values that is, and that only is true when your x values are between negative 2 and 1/2. Okay, and then you'll go over to the next piece. Let's call this part C right here, and let's say this is the coordinate 1/2, 2, and up here is the coordinate 1, 3. Okay, and if I figure out my rise over my run, my rise I went up 1, and my run I went over 1/2. So if you do 1 over 1/2, that gives you a slope of 2 when you flip that. Okay, so for part C, I'm going to use this equation, y minus y1 equals m, which I already figured out was 2, times x minus x1. Okay, so I'm going to use the coordinate 1, 3. You can use whichever one you want. So y minus 3 equals 2 times x minus 1. Okay, or y minus 3 equals 2x minus 2, or y equals 2x plus 1. Okay, and again I need to stipulate what x values that is for, so that's only for when x is between negative 1 or positive 1/2 and 1. So I would have to do this. Okay, and then of course you'd have to have one for part D as well. This part over here, I'm not going to take the time to do it. I think you guys can find the equation of that line. But notice how you have to have an equation for each piece of that piecewise function. All right, and lastly, I am asking you to figure out this one, and actually, yeah, this one right here. Okay, so I assume that you guys can kind of figure out the equation of a line. So for this piece right here, you can see that it crosses the y-axis at 1, and that it has a rise of 3 and a run of 3. Okay, has a rise of 3 and a run of 3. So your slope is also 1. So for this piece right here, this one right here, I have a y value of, or an equation of x plus 1. A slope of 1, it crosses the y-axis of 1. But I need to stipulate again where that is for. Notice this is a closed-in circle right here, so x can be exactly 0, but it's an open circle right here, so x can't be exactly 3. So it needs to look like this. Okay, so that's one piece of my function, is that right there. And then I need to have another piece for this down here. Okay, and so I need to figure out what that is. Again, you can kind of use coordinates, And you could use the coordinate down here of 3, -1, and right here of 4, 0. And clearly you can see that your slope right here is, I go up 1, right 1. It's also parallel to the other one, so you know it's going to have the same slope, which would have a slope of 1. So down here, your y equation has a slope of 1. And then if you kind of figure out if it goes down 1, left 1 every time, down 1, left 1, down 1, left 1, down 1, left 1, it will cross the y-axis down there at -4. So it'll be -4 right there. But again, you need to stipulate which x values that happens for. So right here, your x can be exactly 3. So it can be exactly 3, and it can be anything bigger than that 3. My x values can be anything bigger than 3 because I'm moving to the right of 3. I have no end cap on the top. It just has to be bigger than 3. So you know what? I'm going to do this. Usually you put it like that. Okay? I need both of these on there. Typically they're written together, but I do need them both on there. I'll get them. You'll see how they're written on the next example. Last one right here. This time I gave you the equations. See how they're all written together like that? And I gave you the stipulation of where they are. So I'm going to start with this first one right here, which has a slope of -1, and it crosses the y-axis at 0. So it crosses the y-axis at 0, has a slope of -1. So it will look like this. I'm just drawing it dotted right now. Notice that that is the equation only for x values that are less than 0. Okay? So if you think about it right here, your x value right here is -1. Your x value right here is -2. Your x value right here is -3. But up here, your x value is +2. And my x values have to be smaller than 0. So none of these are going to work. I'm going to erase them. My x values have to be smaller than 0. Not exactly 0, smaller than 0. So open circle at 0, and then I'm going to shade down like this. Okay, so that's the first piece. Then this is a parabola right here. Okay, parabola at x squared normally would go right here. And then I'd go 1 up, 1 right. And if you need to use your graphing calculators to help you and to get a table, you can do that, or plug in some numbers. When I plug in 1, I get 1. When I plug in 2 for x, I get 4. So it would look like this. When I plug in -2 for x, I get -4. Okay? So normally your parabola would look something like this. Okay? But notice I only can have it when my x values are between 0 and 1. And my x value can be exactly 0, and my x value can be exactly 1, and it can be anything in between. But that's it. The rest of it has to go. Okay? And then lastly, I have a y value of 1. So now I have a horizontal line here at 1, and normally it would go this way too, but again, I can only have that horizontal line when my x values are greater than 1. Okay, so I would actually, the blue part would have an open circle, but it's filled in by the, you don't really need those open circles because the green fills both the red and the blue circles in, so you don't really need to worry about that. But your x values need to be bigger than 0. So right here your x value is 2, right here your x value is 4, right here your x value is whatever. Down here your x value is -3. That's not going to work. So this part of that graph would need to be erased. Okay? And that should do it for today.